So one of the most common applications that we use exponential models for is for compound growth, or most commonly compound interest. So this is the formula that we use when we're talking about compounding things a specific number of times a year. So this is our initial amount. We can see we have 1 plus the rate divided by the number of times a year we're going to compound. And then notice here it's raised to the n times t. Okay, so this is a little bit different than what we did before. So we want to make sure that when you're reading problems, the way they describe n is they're not always going to give you numbers, right? N could be described in words, and you are expected to know how to translate those words into the appropriate number. So watch out for words like monthly, quarterly, daily. So n is the number of times a year, all right? So, and also you want to make sure that your percentage rate is still converted into decimal form before you start a problem. So let's look at an example. It says, determine the value of an account where $1,500 is invested, earning 2% annually, and compounded the following ways. Round your answer to the nearest cent. So the first thing I'm going to do is I'm going to set up the model, and I see here that what's changing in the problem for each part is the value of n. So I'm going to set this up. There's my initial amount. There's my 1 plus my rate in decimal form. There's my n. And we're only going to find the value of the count at the end of a certain specified amount of time. And so we're going to do this at the end of 2 years. So I'm going to plug in 2 for t. So I have 2 to the n. So I need to figure out, based on these values of n, right, how does this change the amount of dollars in my account? So if we do this annually, then n is 1. If we do it semi-annually, that means twice a year. Semi means half, so we do it every 6 months, so that's twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly is 52 times a year, and daily, we just assume we're not in leap year, so we would do it 365 times. So there's a way to very quickly answer all of these in the calculator. And so what I'm going to do, so I'm going to go to my y equals and clear my models. And I'm going to put this model into the calculator. So 1,500 times 1 plus 0.02 divided by n, so we're going to use the x for our variable, close parentheses, and then I'm going to raise it, and I got to put this in parentheses, to n. All right. Now, since n is actually the variable that we're working with here, I need to go to my window and I need to make sure that I make my scale so that I can do all of these values at the same time. So I'm going to let x start at 0, and I'm going to let it go up to 375 because I want to go past 365. And I'm going to graph. I can't see the graph, and I don't actually need to see it for what I'm about to do, but it is a little weird to work with a blank screen, so I'm going to zoom fit just to see something. Okay, so it starts at 1,500, right? And we start seeing that the amount of money we're earning, it's growing, but it's reducing over time as we grow. So now what I can do is I can go into my calculator and I can say, well, second calculate value. And now I can plug in all the n's. So at the end of 1 year, I have $1,560.60. And I'm just going to round these to the nearest penny. If I don't touch any other buttons on the screen, I can just keep entering n's. So now I'm going to say, well, when n is 2, $15,060.51. If n is 4, I get $15,061.06. If n is 12, I get $15,061.16. If n is 52, I get, sorry, I'm saying 15,000, I mean $1,561.20. And if n is 365, I get $1,561.21. So we can see that the amount of money that my account is earning is going up, right? But it's going up by a little bit less each time I compound. So I gained, oh, sorry, this 51 should be a 91. Some of you are probably screaming at me for that. All right, so here I gained 31 cents extra by just compounding one extra time a year. And then I only gained 14 cents, right? And then I only gained 8 cents or 10 cents. And then I only gained 4 more cents. And then I only gained a penny. So that's what the picture was showing us. You'll keep growing your money, but the rate you're going to grow is going to decrease as we increase this, the number of times we compound. And what it's doing within this formula is every time we pay the interest, the next time we pay the interest, you're earning interest on not only what's in your account, but on the previous interest you've already earned. So that's what I mean by we're compounding the money.